Hello everyone, my name is Lewys Brace. I'm a lecturer at the University of Exeter where I'm part of the Q-Step Centre, and I am hosting this NCRM workshop on text data analysis. This workshop is going to be broken down into three parts, as denoted by the three separate videos. Part one, which we've got up on the screen here now, is going to be a very quick broad overview introduction to Python. Okay, it's going to be very quick, and we're only going to look at the elements of Python that we'll need in order to do the tasks we're going to look at in parts 2 and 3. Part 2, we'll then look at using Python to collect textual data, i.e. how to scrape a website. And then in part 3, we'll look at some basic introductory analysis techniques that you can use in order to analyze text data. So each of the three videos will also be accompanied by what we call a Jupyter notebook. Okay. In the broadest sense, you can think of Jupyter notebooks as interactive textbooks. So you'll see as we go along through today's session, I'll have these notebooks up on the screen, and you'll see they contain a lot of text, but also further on down, they have some interactive Python terminals. And these terminals here are interactive, so you can edit them on the fly if you want, and run them, and they'll still run exactly like they would if you were running Python code in your IDE. If you look in the material supporting resources materials folder for this session, you'll find some PDFs in there that I've put together that will show you how to download and install Python onto your computer. Those guides show you how to download the Anaconda distribution of Python, which is the distribution I recommend my students download and use. There are other distributions as well, such as the umbrella distribution and so on, which are perfectly adequate. There's a new distribution out called PyCharm, which I've heard is pretty good. I haven't gone to using it myself yet, but the user guide you've got, and like I said, what I tell my students to do is download Anaconda. The reason I tell them to download the Anaconda distribution is because it contains a lot of the libraries and packages you'll be using in Python, which we'll cover towards the end of this first session, come pre-installed with Anaconda. But the Anaconda distribution also contains not only contains the Spider IDE to enable you to edit and actually run Python code, but it also contains the software you need in order to be able to run these Jupyter notebooks. So, if you follow his guides, if you don't already have Python on your computer, if you follow his guides, they should be able to take you through the step-by-step process of downloading Python, downloading Anaconda, installing it on your machine, and opening Jupyter notebooks as well. If you have any issues with doing any of that, my email address is on each of these Jupyter notebooks, but it's also on all the documentation stuff you'll see when you download the materials folder. So just feel free to drop me an email if you have any issues, and I shall help you to the best I can. Okay. With all that said, let's start our introduction to Python. So, learning Python for the first time. I have no idea why this image exists, but it often presented to snakes it's kind of what it feels like learning a language for the first time. Okay, so as I said a moment ago, this first part of today's session is a very quick introduction to Python. We are only going to cover the bits that we need in order to be able to understand the code that we're using to collect Python data and analyze it later on. Okay. As such, there's going to be large parts of Python I'm going to just skip over because we don't have time to go over the language in that much detail today. If you follow this link to the Exeter Q-Step Resources GitHub page, On there, you'll find a lot of introductory Python materials I've developed previously. And so you'll find previous workshops and courses I've developed and done that have introduced around the concept of learning Python and using it for data analysis and stuff like that. And you'll find these workshops are a lot more in depth than what we're going to do today. And so if you're interested in learning Python more and developing your knowledge and skills with this language, I suggest you click on that link and take a look at those resources. All the resources contained on this page are open source, which means they're free for you to use. And likewise, as you're going through those resources, if you have any questions, please just feel free to reach out to me. I'm happy to help. Okay, so what is Python? The sort of official definition of Python is that it's a high-level, interpretive, generic programming language with a batteries included philosophy. Now that's a very long, complicated sentence, but what does it actually mean? Well, as you can see from my slide here, there's four main components to this sentence. That it's a generic programming language, that it's high-level, that it's interpretive, and that it has this batteries included philosophy. A general purpose programming language is a programming language that is designed to be used in the widest possible variety of contexts. Okay, so with languages like Python, Java, and C, you can use them for a wide range of different functions. You can use them for data analysis, you can use them to interact with APIs, you can use them as the base of some kind of other software, and so on. For those of you who are familiar with R, for example, R offers a good contrast to Python in that R is technically a form of scripting language, right? Because it's designed specifically to do statistical analysis. I know in recent years it's been developed a little bit more and it can now do other stuff such as text data and some web scraping and so on. But at its core, it was designed to do statistical analysis. So that is not a generic programming language because it has this one sort of main aim in mind. Whereas, like I said, Python, Java, C, and so on can be used for a whole range of different tasks. The second aspect of Python is that it's what we call a high-level language. And what this means is that the syntax of a language, i.e. how the code looks when you type it into your terminals or your user interfaces and so on, it looks more like a natural language, okay? i.e. it's more sort of English than it is when you compare it to other languages. So if you look at the code syntax for C, for example, unless you're familiar with that language, it looks almost alien. It's hard to understand. It's not immediately intuitive as to what the code's doing or saying. If you compare that to Python code, Python code is pretty obvious from the get-go, even if you're not familiar with it. And you'll start to see this as we go along during the first part of today's session. It's an interpretive language, okay? What does this mean? This means that your code isn't directly run by this hardware. Instead, when you write your Python code and you run your Python code, your Python code is not automatically converted directly into machine code, okay? And by machine code, I mean that your computer doesn't understand the languages you type, okay? So when you have Microsoft Word open, for example, and you type your sentence, the cat sat on the mat, right? The computer doesn't understand the words, the cat sat on the mat. It's not dealing with the words. Under the hood, right down at the bottom, each one of those characters is being converted into a series of zeros and ones, okay? And that's how the computer understands it. When you write your Python code, your code isn't automatically directly converted into zeros and ones, okay? It's sent to a special piece of software called the interpreter. And the interpreter then converts your Python code into machine code that your computer can understand and work with. This is compared to C, where you run your code, and in order to run your code, you need something called a compiler, which compiles your language together and converts it directly into machine code. And as we'll see in a minute, the fact that Python is interpretive means it has a whole host of benefits, particularly where we're concerned for the kind of tasks we want to do today, such as text analysis and so on. Finally, Python has this batteries included philosophy. This means that if you want to do a task, okay, the chances are there's something called a module out there which already exists to do that task. Modules are pre-built bits of Python code that people have built in order to do a very specific task. So, for example, if you wanted to create some graphs, okay, if there was not a module for creating graphs, you would have to, in your programming language, first create the canvas that you want your graph to be on, then you'd need to create each of your individual axes, and then the axes labels, and then the data, and so on. In Python, however, because it has this sort of batteries included philosophy, which refers to these modules, instead you could just say import my graph module and feed in this data and produce me a graph. Okay? It makes it a lot easier for you. And there are modules to do a whole host of different things. So, for example, here, we're going to import anti-gravity. And if we import the package anti-gravity, it just takes us to this little comic strip. And that's just a sort of very silly example of a Python package. Okay. In reality, there are so many useful packages. Like I said, I've already mentioned the graphing one. One of the most fundamental packages you'll encounter is called Numpy, which stands for Numerical Python, which is a package that's designed to do large-scale numerical calculations. One of the other main packages which we'll come across later on today is Pandas, which is designed to basically allow for easier data analysis and data wrangling in Python. For those of you who are familiar with R, this whole idea of modules is exactly the same as the concept of libraries. Okay, so what are the advantages of Python? As I said a minute ago, Python is an interpretive language, which means it has a number of advantages. Firstly, it has automatic memory management. What does that mean? Well, it means that the computer works out how best to run your code for you. So to contrast Python with C, the programming language C, as in just the letter C, for example, when you're coding in C, you need to use these things called pointers. And pointers are essentially a way that basically involve you telling the computer what part of the memory to use when it's executing a specific part of your code. Now, this can become very tedious, as I'm sure you can tell from the anger in my voice. I've had to deal with these quite a lot. Python, however, says, don't worry about that, I'll do it all for you. And Python has some very clever algorithms that operate under the hood, but you don't have to interact with in order to do this kind of memory management for you. It is worth mentioning that you can edit these algorithms if you want, so you can customize how the memory is used and how your Python code is run. However, I personally have never felt the need to do that, and I do some incredibly computationally heavy tasks. But I've so far found that these algorithms are efficient enough that I haven't had to alter them. As I mentioned a moment ago, the syntax is in English, so a natural language makes it nice and clear and easy to understand. This makes programming, a lot easier in Python as compared to other languages, which in turn minimizes development time. Okay, it's quicker to develop a script in Python than it is other languages. And as I said, Python has this emphasis on importing modules, which makes life so much easier because it means you don't have to build everything from scratch all the time. Okay. However, as much as I like Python, it's worth mentioning that there are some disadvantages to it. Firstly, interpretive languages such as Python tend to run a lot slower than compiled languages. So just as a rough estimate, if you developed a script in Python and then developed a script to do the same thing in C, the C version of the script will run roughly 8 times faster than that of the other script in Python. Okay. This means that there's a sort of trade-off to be made. Okay. And as you can see down here, where I say which language is best, there's a whole bunch of factors you need to take into account. Okay. And this graph is particularly prevalent to this sort of C Python example, okay? So for example, I could develop like I said, a script in C and a script in Python to do the same task. And the one in C might run 8 times faster. But because because it's so much harder to code in C, it might take me 20 times as long to actually build the script and actually get to a point where it can run. So I often have to make this trade-off between efficiency in terms of CPU time and how long it's going to take to run the task versus development time. And because I'm quite lazy, as most computer scientists are, I often choose the lower development time just so I can get the script working, and then I just let it run in the background while I go off and do other things. The modules we import are developed in a decentralized manner, which basically means that they're developed by nerds for nerds. Okay, and there's no sort of oversight body that does quality control with them. Okay. However, despite that, it is worth mentioning that the internet sort of created this sort of natural selection sort of mechanism for packages, in that packages that aren't very good don't tend to get discussed much, whereas packages that are really good get talked about by the online community a lot and get shared a lot more. So there's that kind of natural selection approach to it, even if there is not a centralized body monitoring the quality of them. And multi-threading used to be difficult in Python, but it's got a lot better in recent years, and even that is fairly straightforward now. Versions of Python. Okay, so it's worth mentioning quickly that when you look at Python, there's 2 main versions out, Python 2 and Python 3. And this refers to the way in which Python is a relatively young programming language. Okay, and that means that when Python was released to the wider public in the form of Python 2, as people started to adopt it and use it more and more, they found some issues with it that needed correcting. As such, there was eventually this huge overhaul of the Python language, where large parts of it were sort of redeveloped and tweaked a little bit, and this was released as Python 3. The syntax for the 2 is slightly different, okay? And this is the main reason I mentioned this, is because if you Google Python code examples, you might sometimes see little differences between code examples if the code example you're looking at is sort of 10 years old or so, okay? Whereas more recent examples will look slightly different, okay? So just do bear that in mind. There are some differences in the syntax. However, that said, all of the modules that are used widely have been updated for Python 3 now, and indeed Python 2, as of last year, isn't even supported anymore. So everyone out there is using Python 3 now. But just be aware, if you're on your websites like Stack Overflow or so on, and you're looking at a particularly old post, the syntax might look a little bit different. Okay, so that's the sort of background to Python. And let's start to look at it quickly now, and how to actually code in this language. Okay, so variables. For those of you who are familiar with R, you'll perhaps be familiar with variables. They pretty much work exactly the same way here as they would in R. For those of you who haven't done any programming before, you can think of variables as being alphanumerical characters that stand for something. Okay, so for example, if we look at this example down here, okay, here's some Python code. Okay, and this line here says int var equals 5. And if I were to run this line, right? Actually, let's run this line. Okay. So I run that, okay, and yes, it looks like nothing happened, but something did happen. What this did here was tell my Python terminal that whenever I type int var, I want it to equal 5. Okay, so if I say print int var, this print word here is a function which we'll get onto in a moment, but basically, as I'm sure you can tell from context here, this just says print this variable to the screen. Okay, that's all that line says. And if I run this, you'll see 5 comes out, because Python now knows that the term int var equals 5. Okay, right. Now, by convention, it's common to have variable names start with lowercase and then save uppercase letters for other things such as classes and so on, which again we'll get onto later on. That's the convention that most people use. However, if you're coding just for yourself and not as part of a team, then you can pretty much do whatever you want. But I would recommend that at the very least you remain consistent with yourself. Because if you start mixing up capital letters and lowercase letters just as you're going through your code, it's only a matter of time before you trip yourself over. Some keywords cannot be used as variable names because they have built-in functions in Python. For example, the print. Okay, so you can't have a function just called print, because if I was to try and do that, I could type. If I was to run this line of code here, Python would throw an error message and say I can't do it. And Python's pretty good because it tells you, right? Because the text isn't black, it's green, so that's Python's way of sort of telling you, no, you can't use this because this is a function and has a very specific role to play in Python. Other examples of keywords you can't use for variable names are things such as and or, and you'll start to notice these as you go along and start to use Python more and more. Like I said, your IDE will always let you know by putting the word in a different color anyway. Okay, so in Python, you'll find all the normal variable types that those of you who are familiar with doing data analysis or anything like that would be familiar with. For those of you who don't, the kind of variables you see are pretty self-intuitive. So you have the integer variable, such as this one here, which is just numbers 1, 2, 3, 4, so on. Float, which refers to sort of decimal point numbers. So here we have 3.2, equally you could have 6.1, 8.7, whatever. String, which are word variables, letters, stuff like that. So you see here we've got a string variable, and then we've got our speech marks, and in there we have our word, if you will, which is food. It's worth noting you can also use single speech marks, but you have to make sure you're consistent. So having one double speech mark at the start and one single one at the end isn't going to work. It will throw you an error message. I recommend that when you're dealing with strings, you always use 2, because this allows you to then do things such as apostrophes within the string. It's also worth noting, because we're dealing with text data in this workshop, that if you're looking for a match using a string variable, then Python treats anything contained within these speech marks literally and looks for an exact match. So if I said, for example, Python, tell me if this sentence contains the word food, but I wrote the word food with a lowercase f, when in the sentence it's spelled with an uppercase f, Python will tell me that that word is not in that sentence, okay? Because it doesn't deal with capitalization. It's looking for an exact match, okay? So it's looking for the word food with a lowercase f instead of a capitalized f. And then we have classes and stuff, which we'll get onto later on. So here you can just see some examples, and if I ran this, you can see I created 3 variables, an integer variable, a float variable, and a string variable. And I've used the print statement, which we looked at a moment ago, just to print each one to the screen. Going back to what I said a moment ago about the differences between Python 2 and the Python 3 syntax when you're looking at examples online, a giveaway as to which syntax you're looking at can actually be seen with a print variable, because in Python 2 syntax, the parentheses are not required. So print statements look like this, okay? Whereas in Python 3, we use the parentheses. So that's just a quick way to tell which version of the language you're looking at. And here's just an example of what I was saying about the example of the food and it looking for an exact match, along with some other examples here. Type is another function, okay? And as I'm sure you can guess from its name, type tells you what the type of the variable is. So here I've just said, look, I've got my variable called int bar. I feed that into the type variable, and then I in turn feed that into the print variable. okay, which sounds complicated, but all I'm saying here is, right, print to the screen the type of the integer variable. Do that. Oops, sorry. I do that, and it prints this out. So it's class int. Okay, so it's telling me that the variable int var is an integer, which it is because we assigned it to number 5. Okay, and this example here is just sort of a further example of what we just looked at, whereby you can embed functions within one another. You can also convert variable types. So if you look at this example here, if I run that, you can see we have our first variable, which is 295.50 divided by 2, which obviously creates a floating point number. And we can see that from both printing out the variable there and also print out the variable type, which comes out here. You know, on these print statements here, you'll see I've got a string here where I have, in this case, 1 colon space, 2 colon space, separated by a comma. All I'm telling Python to do here is to print this to the screen and then print the variable. That's just so I get output like this, where I see 1, 2, 3, and that's just so I can easily match up each of the lines of the statements to the correct print statement in my code, just so I can sort of match it for my own eye. And yeah, if we then take the variable, which at this point here is equal to 147.75, and I feed that into the integer argument, so the integer function, it converts it into an integer. Okay, it's just the way of converting types. That brings us to operators. So operators work in exactly the same way as any of you sort of done maths at school or any form of, while programming before would understand. Okay, so you have your addition, subtraction, multiplication, which here is 1 star, division, which is /, and then to the power of, which is 2 stars. Okay, this is just an example. Here we create a variable called x, which is equal to 10, a variable y, which is equal to 2, and then a variable z, which is x divided by y, and then we ask it to print z, and you see it gives us 5, which is the result of dividing 10 by 2. There's also this thing called the increment operator. So in most languages, if you have a variable x here, and you wanted to add 1 to it to make it 11, you'd have to type x equals x plus 1, okay? Which is intuitive, but typing that all the time is a bit lazy, so it requires a bit of effort. And as I said a moment ago, computer scientists are inherently lazy people. And I can say that because I'm one of them. And so they created this thing called the increment operator, which means if you want to add 1 to our variable, you can just type x plus equals 1, and that will do exactly the same thing as if you were to type x equals x plus 1. Okay? And this increment operator works for all the other operators as well. That brings us to Boolean operators. And these are useful and quite often used in conditional statements, which we'll get onto in a moment. And these include things such as and or not. So if you have a conditional statement, which again we'll cover later on. So if you want to say, if int var and float var equal this, do a thing, you'd use the and. Okay, but if you want to say equally, you can say, if int var equals 5 or 7, do a thing. Okay, so it's just a way of combining these sort of what we call conditional statements together. Okay, and they're conditional statements because they're saying, we're only going to do this thing if this condition is met. But like I said, we'll cover that in a second. Comparison operators, pretty much self-explanatory. You have a number of different ones. You have greater than, which is an arrow pointing to the right, lesser than, which is an arrow pointing to the left. Don't worry, I've been coding in Python for years, and I still often confuse the two sometimes. Greater than or equal to, which is a right arrow followed by an equals, and a lesser than, which is a left arrow and an equals. And then there is equals to, which is 2 equals. Obviously, is equal to is 2 equals because 1 equals is how we create a variable. Okay, and if you try to use 1 equals here, let's So in this example here, Python would throw an error message at you. Okay, so here's just an example. We have two variables, int var and float var, and I say if int var is greater than float var, print int var is larger than float var. And this is an example of a conditional, by the way. Okay, because we're saying if this is true, do this. Okay, and because int var is 5 and float var is 3.2, we print we get this output because that condition is true. We say if int var is equal to 5, print int var is equal to 5. Okay. If I say if int var is greater than 5, you'll notice we no longer get that output. Okay. Now, just a quick note to remember the difference between greater than or equals to or greater than and equals to variables. Functions. So there is a difference there. And I know it sounds silly, but this is one of his silly little mistakes that trips over even experienced programmers. So just remember, just remember the difference between greater than or equals to. So in this example here, we have int var and int var 2 both equal 5, and so we say if int var is greater than int var 2, print this. Okay, which this obviously isn't true, so it doesn't print. Then we say down here, if int var is equal to or greater than int var 2, print this. And we do get that printed out because int var and int var 2 are equal to one another. Okay. So hopefully that makes sense. I apologize that I'm rushing through this, but like I said, we don't really have much time to spend on basic Python here. And so if you want to go over any of this stuff in depth, look at those resources I mentioned at the start of the session, because there are workshops such as this that I teach where I go into a lot more depth and take a lot more time to explain each of these sort of concepts. Okay, so indexing. I want to cover indexing because it's going to come up a lot in the rest of this workshop today, and it's a very important thing to understand. Okay, so indices enable us to access specific elements in a sequence. Okay, so here a sequence can be anything. It can be a data storage list, which we'll look at in a moment, or it can just be a string, a sort of, a string either consisting of one word or a sentence or whatever. Okay, and an element is a specific character within that sequence. So in this example down here, our elements are each of the letters and the white space in the string. If it was a list of numbers, then it would be each individual number. It's very important to note, and this is especially true for those of you who have used R before, that Python, like all other generic programming language, is a zero index based system. What that means is that the first element in any sequence has an index location of 0. The second element then has an index location of 1, and so on. So if we look at this example here, okay, we have a string, which is a pretty truthful statement, dogs are better than cats. We then say print the first element of the test string. And if we run that, you see we get the capital D here, okay, which is the first element. It's also worth mentioning, sorry, I forgot to mention a moment ago, that we do indexing by putting the name of our sequence and then these square brackets at the end where we put in the number of the index of the element we want. Okay, so likewise, if we wanted the O in dogs, which is the second element, but because Python indexing starts at 0, we go 0, 1, so we feed in 1 here, and you see we get the O. Okay, so remember that Python indexing starts at 0. But just to confuse matters, if you wanted to go backwards through a sequence, then the numbers start at 1. So let's say you wanted to get the last element in our string, which is the S in cats. You do your square brackets, and then you put -1, and you get your S. Likewise, if you wanted the T in cats, you run this, and you get your t. You put -2, okay, and so on and so forth. You can get the middle, sort of middle sections of a string, of a sequence if you want, and you do that by having your square bracket as normal, but then feeding in 2 numbers separated by a colon, and this will give you the elements within the range you specify. So here we've got RE space B, so that's the RE from R, the space, and then the B from beta. I highly suggest that. Oh yeah, sorry. Also, if you just wanted the sort of first X number of elements from a sequence or the last X number, you can get that by putting your square brackets, putting in your index number, and then putting a colon at the end or before. Okay, putting colons after the number will get all of the elements after location 5. Putting the colon before will get all of the elements before location 5. And if we run that, you can see the corresponding output there. I highly suggest that if you decide you want to play around and if you decide you actually want to do some text data analysis using Python, I highly recommend checking out the resources I mentioned a moment ago and spending some time with those resources and playing around and learning indexing. Indexing is something that trips over everyone. Even experienced programmers such as myself often make silly mistakes of indexing, and it causes us a lot of issues. So it's one of those things that's worth playing with just to make sure you fully have a grip on. At this point, I just want to mention commenting out code. Quite often you'll write a bit of code that you don't want to run for a while for whatever reason, whether it's just draft code, whether you just don't want to run that specific part of it, whatever. You can run, and if you don't want to run this code, you can stop it from running just by putting a hashtag in front of that specific line of code. So if we run this, for example, you'll see that Python runs all the code before the hashtag, but not after it. Likewise, if I put the hashtag in front of here, you'll notice we get no output because Python's ignoring it. Okay, just a handy little way of blocking out code. Right, that brings us to data containers. So Python has a number of what we call data containers. And you can think of these as sort of computerized Tupperware, really, in that it's just a way for us to store something, whether that's a sequence of characters, some data, whatever. And there are different types of data containers in Python. Okay, some you'll use more than others, but each one has a very specific purpose. And it's worth being familiar with all the major ones before you do any coding in Python. The first data container we'll look at are dictionaries. Now, dictionaries in Python essentially work exactly the same way as a language dictionary does in the real world. Okay, i.e., you have something you want to look up, and you have a definition. Okay, so when you open up, the Oxford English Dictionary, whatever, you know the word you want to look up, and let's say you want to look up the word bacon. You go to B, BA, and so on. You find the word bacon, and it gives you the definition of bacon. Okay. In Python terminology, the thing you want to look up, i.e., the word in our dictionary example, you want to look up is called the key, and this sort of definition, if you will, is known as the value. Okay. So dictionaries in Python are often referred to as key-value pairs. So we have an example here, right? So here I create my dictionary. And dictionaries are denoted by the little squiggly brackets here. And I'll create a new dictionary called prices. Okay? And each entry into my dictionary is separated by a comma. Okay? So this is one entry here, this is another entry here, and so on. Then each entry then contains 2 parts. It contains our key, i.e. the thing we want to look up. Here, my keys are strings because they're obviously the names of foods. But equally, these could just be, if you wanted to, these could equally just be integers as well, okay? Or floats or whatever, okay? But here we've got our keys, and then we have a comma, we have a colon, and then our value, i.e. the thing that's returned, okay? So you can see here, this is just a dictionary of some of my favourite food items, and their corresponding prices. And if I ask Python to print out that, we see our dictionaries printed to the screen there. Okay, so what's the point of dictionaries? Well, you'll start to see as we go through to the later sessions today that you can use dictionaries to store data and access them with relative ease. Okay, but just as a brief example here, I ask Python to print to the screen the price of steak is, comma. I then put my prices variable. I then put the square brackets and put in the word steak. And you might notice that this works exactly along the same principle we sort of indexing did a moment ago. Only instead of using a number or an index location, we're using the key from the dictionary. And if I ask it to print this out, you see that Python prints the words the price of steak is, and then space to the screen, and then goes, right, you want, from the prices dictionary, you want the value that's associated with the key steak. So it goes to the key steak, finds the value, and inserts it in for me. Okay, that's a dictionary. Okay, and we'll be using dictionaries later on in part 2. So that brings us to tuples. Tuples are another form of data container. Now, tuples are interesting in the sense that once they are immutable. Okay, and what that means is that once they are created, you cannot change the content that they have. Okay, so you create a tuple as we do here, and tuples are denoted by parentheses, what some of you may know is just normal brackets. And you'll see here, I'll create my tuple containing just 2 elements, 5 and 10. Okay, and I create my tuple, and once I've created it, I can't alter the contents. Okay, so you can't add stuff to a tuple, you can't add new elements to a tuple, you can't remove them, you can't replace them. Okay, and so I know right now you're perhaps thinking, well, what's the point of this kind of container if you can't amend them? Tuples are actually really useful if you have a very specific sequence that you don't want to accidentally overwrite, which can sometimes happen when you're coding. So for example, if you are building a computer simulation and you have some initial seed numbers that are random numbers you've generated, but you perhaps want to run the model a number of different times under various parameters, and you don't want to have to use the same seed numbers every time, and B, you don't want to accidentally overwrite them, then you can store them in a tuple. Okay, things like that are useful. We won't be using them in this tuples much in this session though. What we will be using a lot in this session are lists. And lists are perhaps the most frequently used type of data container in Python. And unlike tuples, they can be amended, so you can add elements to them, remove elements, switch elements around, and so on. And they can also contain elements of different types. So I forgot to mention when you're talking about when you're working with tuples, every element in a tuple sequence has to be of the same type. Okay, so you can't have one integer, a float, and a string. They either all have to be integers, all have to be floats, or all have to be strings, and so on. With lists, however, that's not an issue. In lists, you can have elements of different types. You can have integers, floats, strings, all in the same sequence. So if you look at this example here, we create a list called number list. Lists are denoted by square brackets. Okay, so be careful not to confuse them with indexing. It's perhaps hard to do because each element in a list is separated by a comma, which is obviously not in indexing, so that should help you there. I then print off the list and the type of the list, and you can see here the list is printed containing the integers 1, 2, 3, and it's a type of list. And then in my second list, I'll create this new variable here called second list, and that is again a list, but it contains one integer, the number 1. It contains the list we just created called number list, and a string called hello. And you can see from the printouts down here that Python is perfectly happy with that. It's perfectly happy to have one list inside another list and so on. Okay. Now, whereas tuples are immutable, lists are mutable. So like I said a minute ago, that means you can change the elements in them. And there are a number of different ways to do that. Okay. So firstly, you can use indexing. So here you see we've got, in this first line of the printout here, you see we've got our list that contains the numbers 1, 2, 3. I then say, right, Python, in the variable list numbers, I want you to replace the second element, either I'm typing 1, because remember, Python indexing starts at 0, okay? I want you to get the second element and I want you to convert it to 5. And you can see from the second printout it does that, okay? So Python goes, okay, so 0, 1, okay, so this is the element you want, and it currently says 2, but I'm going to set it to 5, okay? And that's fine. However, if you want to add a new element into sort of the middle of a list, if you will, but you don't want to overwrite any elements, then you can use the insert function. So if you look at this example here, and if I run this, you see, again, we've got our list, which is just called numbers. It contains 1, 2, 3. I then say numbers.insert. Okay, and here we start to see the first example of something that's a little bit annoying in Python, in that not all the functions have the same syntax. And this is just all programming languages have these little nuances, and it's largely due to how the programming language is sort of developed in a decentralized manner. Okay, so whereas with the print statement, for example, we see print and it comes in a different color, and then we put brackets over it. Here instead we have numbers.insert, and .insert is the function, and we're just saying use .insert on this numbers variable. We then have a parentheses, and we say, oh, and this parentheses, this insert function takes 2 what we call arguments. Okay, the first argument is the index location where we want to insert something. The second argument is the element we want to insert into the sequence. So here we are saying insert the string that contains the word surprise into location 2. Okay, so Python looks at the list, it goes 0, 1, 2, and it goes, okay, you want to insert the surprise here, and it does that. And you see in the following printout we have 0, 1, 2, and then 3 there. If, however, you just want to add an element to the end of a list, you can do that using the append function. And append will just keep adding whatever you give it onto the end of a list in the last location. So if we run this, you see we've got our list 1, 2, 3, and then we'll go numbers.append 4, numbers.append 6, and you see 4 and 6 are added to the list respectively. Equally, sometimes you might want to remove elements from a list, and again there are a couple of ways to do this. Okay, the first one is to use .remove. Okay, so here you say we've got numbers, which is our variable of our list, and this is .remove. Okay, you then feed in the elements you want it to remove from the sequence. However, if we run this line, you see that we have our original list here, which contains numbers 1, 2, 3, and 3. If I then use numbers.remove, we get 1, 2, 3, okay? And that's because that's because the .remove function will only remove the first element that matches the element you fed in the sequence, okay? So in this case here, it's only removed the first 3 it's encountered. Okay, so if I was to put another 3 here, for example, and run that, you see that when it prints out, we've still only got 2 3s left at the end because Python still only removed the first occurrence of that element. And so because of this issue, most of the time when you remove an element from a list, you'll delete it using indexing. Okay, and that's fairly straightforward. Right, so here you can see we've got an example. Again, we've got our list, which contains the numbers 1, 2, 3, 4. And then down here, we've got another function. You see we've got del. which comes up in green, because again, del is a reserved function word, which you can't use it as a variable name. And del works by obviously typing the word del, the function del, and then you type your variable name, and then you feed in the index of the element that you want to remove. So here I'm saying remove element in location 1, which is obviously actually the second element because Python is again 0 index based. And if I run that, you can see down here we have our initial list of 1, 2, 3, 4, and when I say remove the element in sequence 2, sorry, remove the element in location 2, and it's done exactly that. It's removed, which corresponds to number 2, which has now been deleted from our list. Okay, so that's lists. And again, looking at these sort of examples here of these data containers, you can start to see why I said indexing is so important and why I recommend you spend some time learning that. For loops. For loops will be used quite a lot in a moment to sort of iterate over things, okay? And that's their main function, is to iterate over a sequence, okay? So when you create what we call a for loop, it essentially says for all elements in a sequence, do something, okay? Whether that's all elements in a list, all elements in a string, whatever your sequence is, okay? So as an example, here we create a list of species, okay? And our species list contains dog, cat, shark, falcon, deer, Tyrannosaurus rex, because I couldn't think of any other animals to add in as an example. And I just ask it to print off this list, and it prints off just like we've seen before, not an issue. We then write our code, okay? We then write our for loop. Now the syntax of a for loop follows something like this. For I in species, do a thing, okay? Now, the I here is just a placeholder, okay? And it's worth noting it could be anything. You could put hat, the word hat here if you want. You could put the word, I don't know, ride here if you want, whatever. It can be anything. Often when you look at Python code, you'll quite often see that I and J are quite often used by convention. There's no specific reason for that other than convention. Much the same way as when you look at sort of mathematical equations, you see X and Y used for variable names a lot. Much the same principle. So our for loop has a syntax of for I in species print I. Okay, so the thing we're doing is printing the element to the screen. It's worth noting on for loop syntax that the indent here is very important. If you don't have that indent, Python will give you an error message. Okay, so that white space there is very important. And if we were to run this bit of code, you'll see that Python iterates through each of the sequences. Okay, so the first time it goes through this loop, it goes for I in species. Okay, and it says to itself, okay, this is the first time I've gone through it, so I'm dealing with the first element, which is dog, so I'm going to print dog to the screen. Second time it goes through, it goes, okay, this is the second time I'm going through it, so I want to look at the second element, which is cat. Okay, and I have to print that to the screen, and so on and so forth. Fairly straightforward. You can also use it, as in this example here, which I won't bother talking you through, and you can sort of read through this in your own time if you want. And you can see here we've got a list of numbers, and this for loop basically just goes through and adds each of these numbers together until we get the total. Break statements can be used to break for loops. We don't really have time to get into them here, but look at the other materials I mentioned before, and I'll talk about them in quite some depth. While loops are a lot like for loops, but also their own thing themselves. So a while loop, whereas a for loop says for all elements in a sequence, do a thing, while loops say, while this condition is true, do a thing, okay? So as an example, here we've got our list of species again, and we've got a new variable called I, which we set to 0, okay? And we say, using a comparison operator, we say, while I is less than 3, print out the element in the species list at location I, because obviously I here is an integer variable. and then add 1 to I. Okay, so if we were to run that, okay, what's going on here? Well, the first time we go through the while loop, I is equal to 0, because that's what we told it to be at. So Python goes, okay, so I is equal to 0, 0 is less than 3, so I'm going to go to the species list and I'm going to print out the species at location 0. And then I'm going to add 1 to I. Then it goes through it again, it goes, okay, so now I equals 1, so I'm going to print out the animal in the species element at location index location 1, which is the second element, and which is cat, so it prints out to the screen, and then it adds I to 1, and so on and so forth until I equals 3, at which point it comes down here and goes, okay, while I is less than 3, and it goes, oh no, wait, I is equal to 3, they're the same, so I'm not going to do anything. And that's why we get dog, cat, shark, and then it stops, okay, because our indexes, our I variables increase. It's gone 0, 1, 2, and then it's equal to 3, so it hasn't printed out anything after that. Hopefully that makes sense. You can also create what's known as an infinite loop. Infinite loops are just essentially where it's a bit of code where your while loop never terminates and it just runs forever. Okay, this is an example of a while loop here. And if you were, I've commented this code out because I don't want it to run, because it will run forever and I'd have to terminate the console. And the reason this runs forever is because we never actually, this line of code here is faulty in that it never actually adds any numbers to I. So I is always 0, which means this condition is never met, which means it just keeps printing 0 to the screen forever. So, for loops versus while loops. You'll probably use for loops more than while loops throughout your coding career. A for loop is a natural choice when you want to cycle through a sequence, whether that be a string with numerous characters in it, a list, whatever. Whereas a while loop is a natural choice if you want to keep doing an operation while a certain condition is true. Okay? That brings us to conditionals. And we've seen conditionals briefly already, all right? Those if statements we looked at a minute ago, those were a form of conditionals. So there are 3 major conditionals that you can use. Those are if, else, and elif. And a conditional essentially says that while this condition is true, do a thing. So here's an example. Okay, we have a variable called work night, and we set this to be equals to true. So it's what we call a Boolean variable. Okay, so true, false, whatever. So we say work night equals true, and then we say if work night equals true with 2 equals signs because it's is equals to, print no beer. Else, okay, print you may have beer. So what it essentially says is if work night is true, print beer. If work night equals anything else, print you may have beer. And if we run that, we find out that it's a work night, so I can't have beer. Okay. If, however, I set work night to false, then you see that we get a much happier result. You can also use elif if you want to have a sequence of true-false statements. And there's an example of that here that you can play around with after the session. Right, that brings us to functions. Functions are really useful bits of code to create if you're going to have to do a task multiple times. Okay, and the reason it's useful is because then you can write the code out, that chunk of code out once, and in the future you can just call it and refer to it, and you don't have to keep typing out individually. So for example, here we have our function. Okay, I've created a function called practice function. Functions are defined by first typing the word def for definition, and then a space, and then a practice, then the name of your function, which I've just called practice underscore function. You then put parentheses, and you put some placeholders for some variables. And the number of placeholders you put here should be equal to the number of variables you think you're going to have to feed into the function. And so I know in this function I want to feed in 2 variables, so I'll just put A and B there. Then there's the colon, and then this important indent. And then in this function, I just conduct the operation, okay? And I say, right, here I want to create a new variable called answer, which is equal to A times B, okay? We then end the function by saying return answer, okay? So what this does is create the function there. And then further on down, I've got 2 variables, x, which equals to 5, and y equals 4, okay? And then down here, I've got another new variable, which is called calculated. And I say, right, this variable calculated is going to be equals to whatever output I get from this practice function when I feed in x and y. So Python runs this, and it takes x, and it takes y, and then it goes up to the function here. And it goes, well, x is the first sequence fed in here, so now x is assigned to A, y is the second argument fed in here, so y is now equal to B, okay? And then down here it says, okay, what is A multiplied by B? In other words, what is x multiplied by, what is 5 multiplied by 4? And it calculates the answer for that, and then it returns the answer, and this variable answer is then assigned to calculated. We then ask it to print calculated, and we get the answer of 20, okay? And like I said, this is useful because it means, later on, if you need to do this function repeatedly, you can just create another function too. And let's say you've got other variables like this. Actually, let's not use L because that looks a lot like 1 on my screen. And then I could just, sorry, I can't type today. And if I just feed these variables in like that, and ask it to print out calculated 2, you'll see it gives us 12 because it's fed in H, which is equal to 6, J, which is equal to 2, and it's multiplied 6 by 2, which has given us 12. Okay, so functions are really useful, like I said, if you want to do an operation multiple times, and you'll see that when we carry on in a moment. You can also have multiple returns, so you can do multiple functions and return multiple things from a function like that. Okay. A word on import. We've covered import a lot already. This refers to what I was talking about at the start, where Python has this sort of batteries included philosophy, right? Where we say there's a module for everything you can need. Just as an example of that, I've imported a different module called datetime, and I've created a variable that says current time equals to the datetime function. Call the datetime function from the datetime package, and from that datetime function, call the now subfunction. And what that does is basically print the current date and time as far as my computer is concerned. Pandas, I'm just going to briefly mention Pandas now because we're going to use it a lot in today's session. So Pandas is another module you can import. And like I said, Pandas is designed to be one of those packages that caters more towards people who use Python for data analysis. And as such, it provides a lot of useful tools that are useful to data analysts, such as easy to use data structures and various multiplication tools and stuff like that. There are 2 main data structures in Pandas that are useful: series and data frames. Okay, and we're going to briefly look at those just to end this first video. So first things first, we're going to import Pandas. But you can see here I've put import Pandas as PD. Okay, you don't need to do that, but what this means is that later on, whenever we call the Pandas function, if I just imported it like this, whenever I wanted to call something from Pandas, I'd have to type out the full Pandas name like that. But because I'm a computer scientist, and as I said, we're lazy, we just say import Pandas as PD. So later on, we can just type PD, and Python knows we're referring to this Pandas package. That's all we do. Okay. So, like I said, Pandas has two main data structures, a series and data frames. The first is a series, and you can think of a series as essentially a list, but with an inbuilt index. Okay, I'm not going to spend much time here looking at these because the additional resource I mentioned before contains a lot of tutorials for Pandas. The second data structure, which is more prevalent in what we're actually going to use today, particularly in part 3 of today's workshop, is a data frame. And you can just think of a data frame as a data table. Okay, so any of you who've used Excel or anything like that before, a data frame is essentially the same sort of thing, right? In that you have your variables and your columns going down and your observations in rows going across. Okay? And Pandas has functions to read in data from a large number of different file formats. So you can read in data from CSV files, from JSON files, which we're going to do in a moment, in part 2 and 3 of this, from SQL files, and even from Excel files if you want. Pandas can also write out your data frames to various formats as well, such as CSV. So you can save them as a separate file. Okay. Just to end this first part of the video, it's worth spending some time looking at packages and so on, so particularly Numpy and Pandas, because they have a lot of tools that will save you a lot of time. Okay, so that concludes the first video of this sort of 3-video workshop. Like I said at the start, this has been a very, very speedy whistle-stop tour of Python. And I apologise that I've had to go so fast through it, but I want to get to the actual subject matter of today. Like I said, if you are interested in learning more about Python, which you will need to do if you want to do more of the sort of advanced textual analysis that I'll mention later on, check out this resources page here. Like I said, it contains a lot of very useful resources, such as a sort of more in-depth introduction to Python and Jupyter notebooks, some workshop materials if you are a social scientist to use Python, how to use GIS in Python, so graphical information, and so on. Okay, so check out that resource. And likewise, if you have any issues, you can contact me via email. My email address is l.brace@exeter.ac.uk. Feel free to drop me an email. I'm always happy to help. Okay, so that concludes part 1. In part 2, now, which is the video after this, we'll start looking at how to use what we've learned here with Python to actually build a web scraper so we can actually scrape a website in Python. Okay, I'll see you in part 2 in a moment.